Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings, and today we're going to be looking at Plotly in Python as a way of visualizing data. Now, Beginners Python and Machine Learning is a weekly event on YouTube at the moment, and after COVID we'll be back in a physical premises where people can turn up in Brisbane to get hands-on with Python. But we'll try with YouTube at the moment. So what we've done, we've created a notebook that you can work along with, and you can also contact me during the session. I'll be watching the YouTube chat, and I'll also be watching Slack chat in the Learning to Code channel. So there's instructions in the video and on the meetup on how to join that Slack if you want to, but if you haven't managed to do that, then try sending me a message on YouTube chat and I'll try to respond as well. Now, you shouldn't need Python installed on your computer for this session, but if you do want to run it locally, we do provide a file as well that you can run it locally. So let's get started. In the link here, this link is on the YouTube description, and it's also in the meetup, and that'll take you to a Google Colab notebook where you can run Python for free. You just need a Gmail account. So I've clicked on it already. That brings this. All right, this is the notebook here, and the first thing you'll want to do is copy it to your own drive so that you can make changes as we go along. So click on this copy to drive, or you can go to the file menu and say save a copy in drive. I'll do the same thing. So I'll do that, and you'll see that when you create a copy to your drive, it gives it a new name, copy of Meetup 95. Tim, that's me, I'll be doing this one, and Plotly intro is the name. Okay, so these Colab notebooks, they're Jupyter notebooks, and they're just a mixture of text cells and code cells. And you can see here, if I hover, I can add another code cell or add another text cell, so feel free to add extra stuff into your copy now. You won't be affecting anything that we do. This top one is a text cell, so it's just a bit of text to describe what's going on. Today we're going to be looking at Plotly, and we're looking at Pandas, DataFrames and series. Here are the links to this stuff, and see this GitHub link that'll take you to where some Python files are if you want to run this locally on Python on your own computer. Right, now Plotly, we need Plotly version 4.5 or later, but Google Colab, it comes with an old version. So if we want to see what version it is, we can, as well as running Python code in these cells, we can actually run on the command line shell commands. So the shell command we want to run is Pip List, and by putting an exclamation mark at the front, Google Colab allows us to run these shell commands within a Python code cell. Now to run it, you can click on the play button here, or I'm going to press Control Enter. And the first time you run a cell in your Colab notebook, you'll find that it's a little bit slow to get going. But what we're going to do, Pip List, Pip is the installer that installs the different third-party libraries like Plotly. List will give the list of everything that's been installed, and then we're going to pipe that, so that's a vertical pipe operator, and filter it through the grep command line program that's looking for the words Plotly, and it sees that Plotly, the version that's installed currently for Google Colab, is 4.4.1. So we want to upgrade that. So the way we do that, once again, we want to run a shell command, so exclamation mark to run a shell command, and pip install -- upgrade Plotly, and that will upgrade to the latest version. So I'll press Control Enter or Shift Enter on that, and it'll download the latest version of Plotly. which is 4.14.3, and it'll uninstall 4.4.1 in our Google Colab area and put in 4.14.3. Right, so the other third-party libraries we'll be using are Numpy and Pandas, and so they'll be just used for getting the data ready, and Plotly will be used for graphing it. So whenever you have a Python program, if you want to use third-party libraries or even the non-built-in libraries, you have to import them at the top of your Python file so that you can then use them later on in your code. So we're going to be using Numpy, Pandas, and Plotly. Now in Numpy, we're going to the convention. So many people use Numpy, and so they don't like typing Numpy all the time. They just want to type NP. So the as NP just makes it a bit quicker to use Numpy when we're typing down low, and same with Pandas. We'll just type PD for whenever we want to use Pandas. Plotly, we'll use the full name of Plotly, but there's different parts of Plotly we'll be using. We'll also be using graph objects. So we'll abbreviate that to GO, and we'll be using Plotly Express, so we'll abbreviate that to PX. Right, so don't forget to run this. So we'll run that one, and after we run it, we'll get a number in that cell that'll tell us that it's been run. And there it is, the number 3. So it's the third cell that we've run. Okay, so I'm going to take a few examples from plotly.com. It tells you how to create and update figures. Now Plotly can produce some pretty good looking graphs, and the way it does that is it's using a JavaScript library with a web front end, and so the Python library is just preparing the data to send to JavaScript. And so it uses dictionaries quite a lot. So Python dictionaries are very similar to JSON objects. So we prepare our data into dictionaries, and we send that off to the JavaScript library, and it plots it. So I'll just, if you want to go and have a look at this site, there's plotly.com, creating and updating figures, and here we go, it's talking about dictionaries. So, but we're going to actually do some real examples. So anything that we're running here, you can run it as well, and you should get the same results. So we're going to create this dictionary. It's got a data element and a layout element, and this data element is a list of other dictionaries, and the layout is just a dictionary which contains dictionaries. So they just love their dictionaries. There's two things we can do. Once we've created that dictionary, we can show it, which means send it off to the JavaScript, or we can write it to an HTML file, and that'll save all the JavaScript into an HTML file on your computer, or in this case we're using Google Colab, so it'll save it in our file store, which you can then download if you want, and then you can move the graph around using that. So let's try running this and see what we get. Okay, so we've got a nice little line graph here. It's got a couple of lines have been drawn up. We've got one that's going up and down. We've got one that just keeps climbing. But some of the nice things that we've got here, we can hover over different parts of it, and it gives us coordinates. So that's coordinates 3, 2 on the up-down line. That's coordinates 2, 3. That's coordinates 1, 1 on climber, and 1, 1 on up-down. And similarly, there's the red ones there. You can also zoom in to parts of the graph, which is really useful. And if you look up here, you've got some extra things we can do. So we had zoom selected. Let's try pan. When pan's selected, we can drag the plot around and look at particular parts of it. So it's quite an advanced charting package. We can zoom back out, zoom in. We can reset everything to how it looks originally, and you can even download the plot as a PNG file. So let's have a look at the data that we've got here. We've got our x values 1, 2, 3, our y values 1, 3, 2. So this is all for the up-down one. So 1, 2, 3, and the y values 1, 3, 2. And for the climber curve, we've called it climber there, and the numbers are x's are 1, 2, and 4, which is 1, 2, sorry, so we're finding the red one, 1, 2, and 4. And the y value is 1, 2.5, and 3.5. And we put a title on there, scatter chart constructed as a dictionary. So it's a little bit tricky having to remember all this format, how to put all the dictionary together, but it's quite powerful what you can do with it. If I look here, I click on the folder and have a look, and you see figure1.html. That got created by this line here, plotly.io.write.html, and it puts the figure that we've created into figure1.html. So it just takes that dictionary, converts it to an HTML file with all the JavaScript to run. So it's a 3.3 megabytes of data there just for these couple of lines. So you can see there's a lot of JavaScript to make that all work. Okay, so here's a challenge. Given the following lists of x and y values, which represent sigmoid function, plot the values. I'll just close this so we can see more, and I'll close this so we can see more. Plot the values in a scatter chart using a dictionary. So I'm going to run this cell so I can see what went into x and y using these Numpy functions. Linspace, which gives us evenly spaced values of x between -10 and 10 and gives us 21 of them, and stores it in an array. And once it's in an array, you can do array arithmetic with it. We're going to use the Numpy exponent function on that array, and that'll return another array. So this is the data we're going to use in our function. So let's create a dictionary. And I find the easiest way is just to copy and paste. Okay, copy cell, copy selection, that's what I want. And I'll paste that in. So we'll create our figure. The type will do a scatter again. X is just going to be our x values that are in a variable. Y, we've already got in a variable called y, and the name, we're going to call it sigmoid, and this list only has one element in it because we've only got one set of data, and we'll give this a title sigmoid. Okay, and so now we'll use Plotly to show that figure, and it should be plotly.io when we're using a dictionary like that. And there's our graph that we've created. We can hover over particular data and see the values. We got our title, sigmoid. We didn't get a legend though, like we did before. So I hope you had a go at doing that. What you can do is pause the video when you get to one of these challenges, have a go yourself in the empty cell, and then play the video and watch the solution on how to do it. You can even watch it at a bit faster than normal speed so that you can catch up to where we're at and ask questions as we're going along. Alright, so here I've actually got the solution down here as well. It's slightly different to what we put in. What's different? Really just show legend is true. So when you put in two data curves with names, then the legend would automatically show. If you've only got one, it doesn't show by default, so you have to specify show legend equals true if you want to see it. So let's try this one, and we can now see the legend is showing over here on the right. Okay, so I started making a couple of changes to this. So what I'm going to do is share this workbook that I'm working on, and so you can have this open in another tab in your browser, and anything that I type, you can just refresh that tab and you'll get everything that I type. So if you're not keeping up with me, this is a way you can get everything and not have to type it yourself. So I'll just copy this link and I'll paste that into YouTube chat, and I'll paste it onto Slack channel. So you can see I've pasted it through to YouTube chat. Let me know if that didn't come through. Right, so we've been, so far we've just done the very basics, which is using a dictionary, and that just gets passed through to JavaScript. Now there's a higher level that we can use to create these figures using Plotly graph objects, which is the GO. We've imported that as GO. And this gives us a little bit more built-in validation, and a few more hints on where we're going wrong, if we've got the names wrong or something. If we're just giving a dictionary, it's just raw data, and it's hard for us to debug where things are not right. So when we do this, we have GO, so that's the library we've imported, .figure, that's a class name, and we create it providing the data and the layout, so similar to what we did with the dictionary, but because we're now using attributes, we can get hints on what needs to be provided. So for example, I'm just hovering over go.figure here, and it tells me I need to provide a data and a layout, and I can provide those other things as well. They've all got defaults, but at least it gives me some hints on what I'm supposed to provide. So for the data, I wanted to provide a bar chart, and there's all the parameters that I can provide to a bar chart, but we're just going to do X and Y, give it a name, and show a legend. Then to write the HTML, it's slightly different. Now I can just call that method straight on the figure object, fig.writeHTML, because this is now a Plotly object of type figure rather than just the dictionary that we had before. And then fig.show is how we can show it using Google Colab. So that data got created pretty quickly into a chart. We can see, we can hover over it. We've got the same controls here for panning and zooming, and downloading as a PNG. And if I look over here, we've now got figure 1 and figure 2.html. So try downloading these as well and opening them up in a browser and just see what they look like. One thing we can do is we can, if we try printing the figure that we've created, it's a graph object, but it's by printing it, it'll show it to us like a dictionary. So it shows us how it's converted to a dictionary the way that we set up the dictionary originally. So inside this figure parentheses, you see the dictionary, and it's reminiscent of what you created before. We had a data and a layout field in our dictionary, and the data was a list of dictionaries, and the layout, we just had a title. We can see this other thing in here called template, and let's just put ... This shows us what's going to be sent to the JavaScript, but the template's actually quite a lot of data that is really not that interesting for us. So they've put in ... because it's unlikely we need to see that. However, if you do want to see it, you can use fig.toDictionary. And once again, you'll see the whole dictionary. And this time the template is spelled right out for you. And you can see all the stuff that goes into that. So any of these things you can override, so it gives you a bit of an idea of all the configuration that's possible in setting up these charts. Okay, so challenge 2, use X and Y from challenge 1 and plot the values using graph objects. So remember last time we created a dictionary. This time we'll create a figure using go.figure. And in the figure we want to specify the data. And that's going to be a list. And then we specify what the type is going to be of our chart. So we want to do a scatter chart. And we'll provide the X equals X, the Y equals Y, and the name equals sigmoid. And then we'll show that. So that's a reasonable way. I didn't put a title in. I would have had to set a layout in there to set the title. And I didn't show the legend. But it's a quick way of getting the chart out. Let's have a look at the solution. So very similar to what I did. Show legend is true. Mode equals lines and markers. Okay, let's run this and see what it looks like, because they've got some different settings in here. So mode equals lines and markers, and you see here we've got the lines, which is the blue line, and we've got some markers, and we've used these hash symbols for markers. The marker symbol is going to be a hash dot. So it's got a hash, and if you look really closely in there, you'll see that there's a dot right in the center. It's a bit hard to see. The marker line width is 1, marker size is 15. So try playing around with some of these things. So what if we changed that marker size to 25 and ran that? You see we've now got bigger markers on our chart. And we've got this title saying we've sigma function constructed from the graph object. So I'll print the dictionary, so you can see what the format of the dictionary is to achieve all these things. And we've figure2.show, so we're showing the graph. So feel free to ask any questions, especially if there's anything that you don't understand. This is supposed to be for beginners doing Python. I've been getting a lot of regulars, so they're starting to learn things, so I might be skipping over things now. But if you're a newcomer, you're welcome to ask really basic questions, and I can help you. All right, so we want to see what all the different markers we can use in our graphs. So on this web page, they talk about this method here, symbol validator.values, and that'll give us all the different symbols that you can use. So like we've used hash dot in this example. So let's run this. And symbols, it produces a list, and it's a weird format they've used. They've given us a number as an integer, they've given us the same number as a string, they've given us a name as a string, and right, so we're getting three values. So here we've got the name is circle, here we've got circle open, circle dot. So these are the names of the symbols. So this is a circle that's filled in, a circle that's open, not filled in. This is a circle with a dot in the middle. This is a circle that's open and got a dot in the middle. All right, now we want to, well, okay, let's have a look at our challenge. Assemble the data into tuples. So the tuple is going to have 4 values. It's going to have the integer ID, so in this case 0, the string ID, which is the string of 0. It's going to have the name of this, the stem of the name. So these first ones, circle, circle open, circle dot, the stem of them is all circle. And it's going to have the variant. So the variant for this one is nothing, the variant for this one is dash open, variant of this is dash dot. So we're just trying to group the data in a way that we can do something more with it. This is the reason we're using Plotly version 4.5 or later, because in 4.4.1 this was a different format. So I wanted to make sure that this is all consistent with the latest, so we can't use 4.4.1, which comes with Google Colab. Alright, so let's assemble this data into tuples. I'm going to create an empty list to put these in. And then I'm going to loop through all the symbols that we've got. So I'm going to go through them in threes. So normally when you're iterating through a list, you just go one item at a time. But because I want every third item, and I want to be able to use the index, I'm going to do a loop in the form for I in range, and the range is going to go from the start at 0. It's going to go up to the length of the list, but we're going to go up in threes. And then once I've got the first one, I'm going to store that into an ID equals raw symbols I. I've got a string ID raw symbols I plus 1, and I've got the name. Okay, now I can put let's see, what's the challenge? Name, stem, name, but removing all the open and the dot. Okay. So I have a variable named stem, and what I'll calculate from that, I'll take my name, which is a string, and I'll look for any variants on there, like open or dot, and I'll just get rid of them. So whenever I see a dash open, I'll just replace that with as empty string, and if I see a dot, I'll replace that with the empty string as well. All right, and the name variant is going to be anything that's left over from the name. So we'll look at the name. I'll use a string slice that'll start at the length of the stem and go to the end, and that'll give me the variant. And what do I want to do then? Similar data into, yep. So into our list, we'll just append a tuple of that data. So we want the int ID, we'll just go ID, string ID, the name stem, and the name variant. And let's print that group symbols. And try running that. Symbols.append. So I try to make mistakes as I go along so that you guys can see how to solve them. Takes one argument, 4 given. Yes. And I meant to put these into a tuple. So I can close that with parentheses. And there we go. So the first one, 0, 0, circle, and no variant. The next one's 100, 100, circle, and dash open. And you can see that's the data that we've got. Circle, split the open out from the circle. So I couldn't just search on dashes and split out everything after that, because some of these names, let's have a look. Here we go, triangle dash NE, that's actually part of the name stem, and the dash open is part of the variant. So that's a northeast triangle and triangle right. Okay, so we've achieved challenge 3. Let's have a look at the solution. It looks pretty similar. If we were just looking for the dash in there to split up the name stem and the name variant, we could have used this, but we couldn't do that because of those other names that actually had dashes in the stems. You can see here I've used a different format of assigning data. I've put 3 values on the left and 3 values on the right, separated by commas, and this is the thing you can do in Python. You can't really do that. Haven't seen it in too many other languages, but it can cut out a few lines of code for you. Alright, well that should be the same. Okay, sort list of tuples by name. So this is a little bit tricky because we've got the name is just one of the is just one of the symbols. This is the name stem actually we'll be sorting on. So it's just the third item in the tuple, index 2. So how do we do that? Well, we'd like to use the sort function that comes with any list. And we need to specify a key and whether it's reversing or ascending or descending. So we can ignore that for now. But how do we specify this key? So this key has to be a function. And when you're in Google Colab, you can actually get, and what I'll do, I'll just create another code cell above here. We can get help on any function. So what we want to get help on is the list dot sort. So list is our data type, and sort is a method of that data type. So if I do question mark list dot sort, it tells me this. It doesn't tell me much about it, but anyway, key has to be a function that is done on the element of the list, that is what is going to be sorted on. So for us to do that, we can define so we'll call it name key, and that'll take one of the symbols, one of the groups, symbol group, and what it will do is return the third element, which is index 2, and index 2. So if I run that and I put this function name in here, I can just put a function name in. And I have to use a keyword. Okay, that's fair enough. And let's have a look at grouped symbols after that. So here we go. Now the A's are at the beginning, arrow bar down, arrow bar left, circle, cross. So it's all in alphabetical order now, based on the name. So you can see what we did here. We had to define a function, and then we put that function name. We didn't call it, so there's no parentheses after name key, apart from this closing parenthesis for the sort function. And then sort will use that function to work out how to sort the values in group symbols. So I'm just going to delete this because it's taking up a fair bit of space. So let's have a look at the solution. In the solution, what was it? Yep. It's, rather than define a function out here, it uses the Lambda function. And so Lambda is a way of anonymizing a function. So if you only need to use it once, you don't really need to give it a name. You just use it the one time and then it's never used again. And it can be used on something that takes variables and returns a single value. So in this case, the arguments that we take is just a single one. It takes t as the argument, so this is the argument that's been given to it, t for the, we just call it t for the tuple that's been provided, and we want to return the second, or the element 2 in the t, which is the third element. And so we can put all that in one line there, saves us a bit of code rather than having to do this in 3 lines. And in the solution, we've also then created lists for each of the different parts. We'll have a list of all the variants, a list of all the name stems, a list of all the symbol names, and a list of all the symbol numbers. So let's run the solution, and there you see. So the name stems, arrow bar down, arrow bar down, arrow bar left, arrow bar left. So you can see there's duplicates there because we're getting each of the variations of them. And there's the variations, and there's the symbols, and they're the numbers. Okay, draw a scatter graph of the symbols, and we want to use mode equals markers. So let's have a look at what that's going to look like. Okay, so we have to provide data, and that's going to be a list, but there's only going to be one in there, so we'll use scatter, and to define scatter we have to provide the x value. Well, let's just what the question asks us to do. We'll set mode equals markers, x equals the name variant, so we've got a list of them, so that's name variants, y is the name stem, stems, and the marker symbol. So the marker symbols we can provide either as numbers or as names. So let's provide the numbers. Okay, let's run that. Marker symbols. What did I? Marker symbol should be. Okay, that created the figure, didn't show it, so let's show it as well. Alright, so that's put all the markers onto the page, and it's for our x-axis we've done the variance, so that's no variant, open dot, and for the y-axis we've used the names. So there's a few problems we've got here with our chart. One is our markers are a little bit small to see. These are all a bit close together. The names are in reverse alphabetical order. Yeah, so let's see how we can fix that, and they've all been fixed in the solution. So the solution is using the update layout, and so we've put a title on the layout. We've set the x-axis range to go from -1 to 4, which means we're showing so it's assigned values to these as -1, 0, 1, 2, 3, 0, 1, 2, 3, I would think. So x-axis range -1, I guess, just gives us a bit more space on the left-hand end. The y-axis range is going to go from the length of the name stems. Alright, so we need to know how many names are going to be here. If you look at name stems, there's duplicates in there. So we convert that list of name stems to a set, and that'll give us a unique list, and then we look at the length of that, and that'll give us how many we've got on the vertical axis. And the range is going from that to -1, so it's reversing them. And that way we should see them, because at the moment it's working up 0, 1, 2, 3, 4, 5, but we want at the bottom to be Y right and at the top to be arrow bar down. Okay, so let's have a look at this. So it's spread them out a bit more. That's good. It's made the markers a bit bigger. It's changed the color of them, so we can now see the outline, and we can see whether it's got a fill color or not. So all the open ones don't have a fill color. We can really see the dots in the dot ones. That's a lot clearer. We've got some we've set some heights and widths here, so it's spread out the data that we've got so that it is easier to see. We've also set we can hover over these, and we've used this template here to say what the name of it is and what the number is. So by hovering we can now, so this is quite a useful graph for us, because it's going to help us whenever we want to draw our graphs. We can have a look at the markers and work out which one we want by what it looks like, and that'll give us our name and number that we can use, and what variant to use to be able to use that on our chart. Yeah. Are there any questions about that? This is really following an example on the Plotly page, but I like the example so much I thought I'd include it in this session. Okay, so that's Plotly graph objects we've worked through. Now another one we can look at is Plotly Express. So that's an even higher level API designed for data exploration. So it links in very closely to DataFrames. So if we create some data frames, we can just do px, which is our Plotly Express abbreviation, say what sort of graph we want to do, line graph, provide the data frame, and then just refer to the columns in the data frame that we want to use to draw the data. So let's have a look at this. The data frames. You could put it in the data frames. Okay, so Leo says we could put it in a data frame and specify the columns. I presume he's talking about the markers at this stage. Yes, we could do that as well. That would be good. So here's our data frame that's been concatenated with df1 and df2. So it's got a group here showing up, down, up, down, up, down, and the data for that, and climber, climber, climber. So by specifying the color here, it's a weird way of saying group, but that's how you can specify which to split them up and show them differently on the legend, is by saying anything in the group column is going to be our color, and then we've got our X data is going to be in the ID column, which is this column here, and the Y column is going to be the score. Okay, so Leo's saying in the data frame our columns could be button object, button text, and button true. Okay, and he's asked how to save figure 5 in a different format than HTML. Okay, let's have a look at figure 5. Right, so this one, you've got these things here, so you could use this camera thing to download the plot as a PNG, and then the PNG you could save, you could convert that to a PDF by printing it to PDF. But yeah, HTML and JavaScript. HTML and JavaScript gives you the interactivity, and that's really one of the big strengths of Plotly. But if you want it, once you've got it right, then yeah, save it as a PNG, and then that PNG you can stick in a PDF without problems. Okay. So that's the data frame. So challenge 6. Yeah, so Matplotlib lets you write PNG as well. And you know, there are some times that I prefer to use Matplotlib, and sometimes I prefer to use Plotly. I find if I've got lots and lots of data, that Matplotlib is a bit more concise with the data. So like these HTML files are 3.3 megabytes and there's hardly any data in them. So once you start putting in thousands of points, it really, Plotly just doesn't cope with that much data, but Matplotlib can still cope with it. So that's where I prefer to use Matplotlib. But the benefits of HTML is it's compatible with Colab for a start. It's also quite good if you're running this from Python on your computer rather than a Jupyter notebook. You can have Plotly throw out a bunch of interactive charts into each one into its own HTML file, and it doesn't have to pause the program as you're looking at each one. But Matplotlib, it shows that it pauses your program, so you have to close the Matplotlib plot to move on to the next one. So there's pros and cons of both, but I think Plotly gives you some nicer looking charts, so if you can use it, I'd probably go with Plotly by preference, but if I've got lots of data, then I'd go with Matplotlib. Okay, using the X and Y from challenge 1, plot the values using Plotly Express. Okay, so let's just, I love copying and pasting, so let's do that. So in our data, we'll have X is going to be all our X values, Y is going to be all our Y values. We don't need a group. We'll just store that in df1. And the X is going to be column X, Y is going to be column Y. And once again, we don't need that. So that's using Plotly Express to draw our sigmoid function. So it's pretty simple. Just create your data frame. That's what the data frame looks like, and then do a px.line on that data frame. So let's have a look at our solution. So in this case, we're going to create the data frame, and rather than have two columns in the data section called X and Y, we're going to put all the Y's into data, and the X we're going to put into the index, and then the column name, which is our Y's, we'll call sigmoid. And then we'll create another column on our data frame called fn to say what function it is we're plotting, which will be sigmoid, and we'll just let color refer to that fn column. So let's run that, look at df.head to see what it looks like, and see how it plots. Now we're going to just, rather than fig.show for Jupyter notebooks, you can just do fig if it's the last line in your cell, and that'll do a fig.show for you. Alright, that worked. You can see our data frame here. So our X's are in the index, our Y's are in the column called sigmoid, and our function name is in the column called fn, and that gives us our legend and our X's and Y's. Alright, Plotly Express comes with some default data sets if you want to practice. So for example, they've got a data in this px.data, they've got one called Gapminder, and it's all got different data from different countries and years. Let's have a bit of a look at the data, and we'll plot the life expectancy out of that by country. Okay, so we've chosen continent Oceania, so the two countries are Australia and New Zealand, and we've chosen, this is the data that's there, so life expectancy, GDP per capita, population. So you know, we could just change any of these. Let's say we wanted population rather than life expectancy, and that's a different chart. So quite some good data there to play around with and practice your Plotly charts. Okay, Leo suggested if you want a PNG file, I think he's suggesting, you can use plotly.io.writeImage. So that's pretty handy. Okay, if you want to look at some of the other chart types, I got a link there. You can go and have a look at those. I'll give you a couple of examples here. For example, here's a Sankey chart. This is one used for energy flows, or in this case, it's how the average personal income tax. So if the average personal income tax for a person in Australia is $10,000, then this shows how much of it goes. And you see how these charts are interactive. You can drag stuff around, which is just amazing. So here, welfare, so it's $3,951 of your $10,000 is going to welfare, and of that, $1,604 is going to aged care, $1,049 to disability, $851 to families. So all it's a pretty useful chart. It's also used. I use these ones for energy flows. Here's another one, the ISO surface plot. I've given you a link there if you want to see some more information on it. So we'll run this one. This one is okay. It's using quite a lot of data. So it's 40 times 40 times 40. So that's 64,000 data points. It's calculating the this ellipsoid function, and then it's calculating surfaces within that. I'll just zoom in. To give us this chart, and some of the things you can do, like you can pan, so you can move stuff around and have a look at it from different angles, which is just pretty amazing. So each of these surfaces is a different value. The blue one there is when the x squared, well, half x squared plus y squared plus 2z squared equals 10. The red one here is when it equals 50, and we've said we want 3 surfaces, so let's put one in there of 30 in the middle as well. So say we wanted the smallest surface to be where the total value of that equation comes to 5. We can run that again. And you see we're now getting a smaller thing in the middle, the value of 5. This value is about 28, 27, 29, and this one's about 50. So 55, yeah, it would be 27.5 will be the purple one. And I just zoomed in and out then using the scroll wheel of my mouse. Okay, so let's have a look at some of the stuff that we've got here. So see here, surface count equals 3. Let's have a look at the dictionary that got created by the way we specified this figure. So we can see here, surface underscore count equals 3, but when that gets translated into the dictionary, it comes in as surface is the name of the key here, and the value is another dictionary which has a key called count and a value of 3. So in Plotly this is called the magic underscore notation, and it just makes it a bit easier to specify things rather than having to specify surface and then having to provide a dictionary with count is 3 in it. We just do surface count equals 3 and it puts it into the right place. So challenge 7, find another example of where we've used magic underscore notation in these plots that we've been doing. So let's have a look back through. Where have we done some plots? So here's one, we've specified marker symbol, so we've got an underscore there, and when we look at it we see marker has created a dictionary, and inside is symbol, and it's got the hash dot. And we've done a couple of here, so we've done marker line width, marker size, so using all those underscores it's constructed the dictionary this way. Okay, so that's good. So I'll go back to the solution. Okay, so yep, the solution here gives the same one. Marker line width equals 1 is equivalent to equal marker equals line width colon 1. You can also do it for layout text. Remember, setting our layout title text was quite laborious, but you can streamline that by just doing layout title text. And so it's pretty much every time you see an underscore here, it's going to be using this underscore magic notation. So let's run this. Oh, and so we've used title text here when we created the figure. We're going to print it out and show it. Then we're going to update the layout, and we'll just use, with this function, update layout, we use title text, and that'll set the text attribute or the text key inside the title dictionary. Or we could just use this update method, and we're going to update layout title text. So let's run these and have a look at how they come out. So you see how we've now got two charts showing in the same output cell. That's because we've done two figure2.shows. Well, in fact, we've done one figure2.show, and then the last line returns a figure, and so the last line of a cell will also get rendered as well. We're printing out the dictionary, so you can see the first one, layout, title, text. There's layout, there's title, there's text, and title created using magic underscore notation, so that got put into the right place. And when we plotted it, it got put onto the title correctly, so that worked. Then our next thing we're going to do is update the layout to say my title updated using title text, and we'll just look at the dictionary for this one. And my title updated using title text, so that worked. And the last one, my title updated using layout title text, we're just showing the graph for that. That's just a thing to help you. Right, so the last thing we'll look at tonight will be just how they did that 3D graph and some of the things that they were using in that example. Let's go back to the graph so you can see they use this mesh grid function in Numpy, and there's three-dimensional interaction between the X, Y, and Z to create it. So let's have a look at what that really means. So you know that in Numpy we've got a couple of ways of creating a list of values all evenly spaced. Previously tonight we've used linspace, where we specify a starting value and ending value and how many values we want. We can also do that using arange, numpy.arange, which is like the Python range function, but Python range only works with integers, but arange in Numpy will work with floating point numbers. So let's have a look at both of those. Those will both give the same results. With linspace, it goes from -10 to 10, and they're inclusive. So you can see the 10 there is inclusive. With arange, it's like Python range. It's an exclusive. The final value is exclusive. So I've had to go to 10.1 to make sure that 10.0 gets included in the space in the range. All right, so there's those functions in Numpy. How can we do that with MeshGrid? So MeshGrid, we specify these values, and we do it in square brackets rather than parentheses. And we can specify a starting value, a finishing value, and a step. And that's very much like arange. So let's have a look at what we get when we do that. So it's almost identical to arange. Now this is doing it in one dimension. And so really we don't need it for that because we've already got arange. But where this works is where we want to do multi-dimensions, which we can't really do with arange. So you can see that gives us exactly the same output as arange. Now what NumPy did here, which has really surprised me when I saw it, is they wanted to also do a equivalent to linspace. Rather than specify the interval between each, so here we specified 0.5, so it went up from -10 to -9.5, and then up by 0.5, and up by 0.5. They wanted to specify how many values they wanted in the range, and let the mesh grid to spread them out evenly. So they wanted to use this notation with the colons inside the square brackets, but they'd already used this notation for a range. So what they've done is they've said, well, Python's actually got different number types. It's got complex numbers as well as real numbers. So by putting a J on it, you're making it a complex number, and that way it looks to see whether the number there is complex or real, and if it's complex, then it ignores the fact that it's complex, just takes the value of that complex number, which is 41, and gives us 41 values between -10 and 10, just like linspace, and in this case the end is inclusive. Right, so our last challenge for the night is create a mesh grid x1 that has 3 values going from 0 to 1, and a y1 value having 3 values going from 1 to 2, and then create an array of all those values where v1 ij is equal to x1 ij squared plus y1 ij squared, and then flatten that into a one-dimensional array so it can be used in a Plotly chart. So let's have a go at this. So I say x1 comma y1, and what I'll do, I'll start with just the grid to see what it looks like, and I use square brackets, not parentheses, and I want my x's to go from 0 to 1, so 0 colon 1, and I want 3 of them, so let's set a step of 0.5, and then I want my y's to go from 1 to 2, and I want 3 of them, so I'll go a step of 0.15, and let's have a look at what that looks like. 0 to 1, yes, and when I'm doing that, remember the final values are exclusive when I'm using a step size, so we'll go 1.1 and 2.1. Right, so I've now got 3 by 3 values for x and 3 by 3 values for y, and they're all stored in the one array. Now I want to break them out, so I'm going to create 2 variables here, x1 and y1, and let's have a look at both of those. So it's a tuple. The first element in the tuple is my x1, which has got 0, 0.5 and 1 in it, and the second value, I'm just going to print those on separate lines so it's a bit clearer. And you see how the x's are increasing, well, they're constant by row, and the y's are constant by column, and so that means that when we're doing things like x1 times y1, we're getting every combination of x times y. And you can see that's the first one, that's the x1, and this one's the y1. Alright, so then we want to calculate our values. v1 equals x1 times x1 plus y1 times y1. And let's have a look at what v1 looks like. And so it's correct, there's our x's, there's our y's, and then if I look at any element in here, so 1 here, that's 0 times 0 plus 1 times 1 gives me 1. Similarly here, 0 times 0 plus 1.5 times 1.5 gives me 2.25. And that carries through for all the 9 elements of v1. And then if you look back at the code that they used, which created that 3D surface graph, they used a flatten function on the array, and that flattened out all these rows and columns just into one long array. And there it is, flattened out. 1, 2.25, 4, and that's what we needed. And so you can see you could do all of that in 2 lines. I use x1 times x1 here. You can also use x1 squared and y1 squared. And we just put the flatten at the end rather than storing it in the intermediate value. So that's the end of tonight's session. Next week I'll be doing some more Plotly, and we'll be going back and looking at some coronavirus data and see how things have changed since last year when we ran a similar session. So are there any final questions? I'll keep watching the chat for a little bit longer, and for people who didn't see Leo's solution, plotio.writeImage is the way to write a PNG from matplotlib, from Plotly. I believe that's going to be a PNG. Okay, I look forward to talking to you next week. The week after that will be an absolute beginners session, and so that'll be for first timers who've never seen Python before, and we'll run you through that. Thank you very much.